Okay, solve the equation. Now, we're solving for the variables x, so we need to list the powers that it has, okay? We have x second and x to the first, okay? So same variable but two different degrees of powers, so we have to apply the factoring properties. So there has to be two solutions to this equation. And zeros here, so you count the number of terms you will be factoring. You will be factoring a binomial, so it'll be GCF, difference of perfect squares. Okay, so we have an x on the end. We don't have the negative in front, then 3 and 9 are 3. Okay. So then I put my 3x factor there for later, and then I go up and divide by 3x. It's like the opposite of the distributive property when you do the GCF, so that's 1. X second divided by x is a cancel, and I have an x remaining. 9 divided by 3 is 3, and then the x divided by the x is a wipeout. Okay, now, this can't be a DOPS because right away it's positive, positive, so we cannot do the difference of perfect squares. So we put no, so then that's okay. We just put that 1x plus 3 with it, and now we're ready to get our two answers using the zero product property. So the zero product property states that 3x could equal 0, or 1x plus 3 could equal 0. So we would divide by 3, and that would be 0. And over here, we don't really need, the 1 is an irrelevant multiplication. Okay, so I would subtract 3, and I would get negative 3. So 0 and negative 3. Okay, number 2, we have 5x to the second power minus 48 equals 0. So I'm solving for x, but we have x to the second only, so there is no need to try to factor here. Okay? It's only 1 degree of x, we want to do linear properties. So we put how many answers there's going to be, which is 2. And we need to find out how many answers there are. We already did that. Collect the x terms if you have more than one. Well, this is my only x term. The operations are times by 5, second power, and minus by 2. So we undo the minus 2 with plus 2. This is linear properties is what I'm arranging on this side, called inverse operations. Then you're going to divide by 5, and then the second power can be undone with a square root. So first I add 2. 48 plus 2 is 50, so 5 times x to the second power equals 50. Then we divide by 5, and that's 10, so x to the second power equals 10. Now I find the square root of 10. Now it's not 5. 10 is not a perfect square. Okay. If it was 5, it'd be 25 in there. So the square, what times itself is 10? It's an irrational number. So it'd be 3.16. So the positive and the negative. Okay. Number 3. 6x to the second minus 5x equals 6. So I have x to the second and I have x. So we are applying the factoring properties. So there's two answers. But I'm not seeing my 0 like I should, so I subtract 6. Now 6 can't be subtracted from that 6 because that one's multiplied by x to the second. Can't be subtracted from the negative 5, that's multiplied by x. So minus 6 is a hang-up. So you just hang it up there. So you have x to the second, x, and the constant. So we have a 6, a negative 5, and a negative 6. So that's 3 terms. It's a trinomial. Okay. That's GCFT. Remember, factoring property is when you're trying to rewrite the expression into multiples of parentheses. Okay, so no x on the end, no negative in the front. Then 6 and 5 are in row 1. Okay, so we won't be doing that, especially without the negative. We don't do that. Okay, so the AC product, 6 times negative 6 is negative 36, so that's a mismatch, okay? Because we need a positive and a negative, so we would add to try to get to negative 5. So 36 divided by 1 is 36, that's negative 35, that's too wide. 36 divided by 2 is 18, so that adds to negative 16, that's too wide. 36 divided by 3 is 12, that adds to negative 9, that's still too wide, but you're getting closer. 36 divided by 4 is 9, so 4 and negative 9 is negative 5, there we have it, okay? So we want to put those into the two parentheses in. So positive 4, negative 9. And the A, x second, that's multiplied by 6, okay? So xx, we know that, and then we apply this 6 in the front. So 6 and 4, okay, that would be divisible by 2. Then the 6 and the 3 are both divisible at the same time by 3. So that gives me 3x plus 2, and then 2x minus 3. Delete that. So 3 times 2 is 6. Bingo. 2 times negative 3 is negative 6. That always has to match up. So we have 3x plus 2 times 2x minus 3 equals 0. So F1, F2. So 3x plus 2 could equal 0, or 2x minus 3 could equal 0. So we subtract 2 and we get negative 2. Then we divide by 3. Now negative 2 divided by 3 is a never-ending decimal, so let's put that as negative 2/3. Okay, now if I add 3 and divide by 2, you're going to get a decimal, but it's not going to, it'll end, it's 1.5, okay? So 1.5, you can write that as 3 over 2 if you want. Okay, number 4, we have x to the second power minus 10x equals 24. So as I look through that, we have x to the second and x to the first, so we are definitely going to apply factoring properties to this. So there would be 2 answers. 0's not here, so again, like on the last problem, you need to subtract 24. So 24 obviously can't be subtracted from the x second term or the x term. It goes in the hang-up. So then we have x to the second, x, and the constant. So x second is 1, negative 10x, and then negative 24. Okay, so we have 3 terms. Again, it's a trinomial, so it'd be GCF and the table. So x on the end, nope. Negative in front, nope. These two would be 1, okay. So 1 times negative 24 is negative 24, and that's a mismatch, okay. Positive, negative, and it's got to add to negative 10. 24 divided by 1 is 24, that's negative 23, that's too wide. 24 divided by 2 is 12, and add 2 and negative 12, it's negative 10, so that's it. Okay, so your A is 1x to the second power, okay. So you put in your positive 2, your negative 12, x times x, and then 1, 1. Okay, so 1 and 2, those can only be divided by 1, and these can only be divided by 1, so it'd be 1x plus 2 and 1x minus 12. Okay, so 1x plus 2 could equal 0, 1x minus 12 could equal 0. Take out your 1 minus 2, and you get negative 2. Take your 1 out, plus 12, and you get 12. Okay, next problem. 3x to the second power minus 2x minus 4 equals 0. So again, you got x second with x. So again, factoring properties is the way to go. So there would be two answers. Before we factor, we need the 0. We have it this time, so that's 3 terms. So that would be GCF, and then the t-table. So no x on the end, negative, nope. 3, 2, and 4 is just a 1 GCF. 3 times negative 4 is negative 12, so the factors have to be a mismatch of a positive times a negative, and for them to be factored, they have to add to the negative 2 in the middle. 12 divided by 1 is 12, that's negative 11, so that's too wide. 12 divided by 2 is 6, that's negative 4, you're still too wide. 12 divided by 3 is 4. Now add those, you're at negative 1, now you're too narrow. So this is quadratic formula. So x equals opposite of b plus or minus d square root b squared minus 4ac, b squared minus 4ac over 2a over 2a. So the opposite of negative 2 is positive 2, and then b to the second, negative 2 to the second, then a is 3, c is negative 4, and then a is 3. So you're going to have 2 in front. 2 times 3 is 6. Now the square root, you have to find what goes on the inside of that. So negative 2 to the second minus 4, 3, negative 4. Okay, I got 52. So the square root of 52, it's irrational. 7.21 when you approximate it. So 7.21. So then I take 2 plus 7.21, click equals, then divide by 6, you get 1.54. Then 2 minus 7.21, click equals, divide by 6, negative 0.87. Okay, x to the third power minus 5x to the second power minus 4x plus 20 equals 0. So we have x to the third, x to the second, and x. So obviously that's applying the factoring properties. X to 3, and if 2 different degrees you have to factor, you're definitely going to have to factor when there's 3 different degrees. So there's 3 solutions. 0's there, now you count how many terms you have to factor. That looks like 4, so it'd be grouping and then check for difference of perfect squares at the end. So grouping, parentheses plus parentheses, then a little parentheses, big parentheses. So we put the one, these are GCF lines. So you put the 1x to the third minus the 5x to the second, and then the negative 4x with the positive 20. Okay. Well, when I have x third and x second, I need to be factoring out x to the second. There's no negative, 1 and 5's 1. Can't factor x out here because the 20 at the end doesn't have it. You do have to factor out the negative. Then 4 and 20 are both divisible by 4. So we would divide by 1x to the second here, and we would divide by negative 4 here. So this is 1, x third divided by x to the second. These cancel, and I have x remaining. Negative 5, x second divided by x to the second is a cancel. And then this is going to be 1x and negative 5. So we have equivalent expressions here with 1x minus 5. Then we combine the 1x second with the negative 4. You can put minus 4 plus negative. And this, we have to check that one where the x is to the second to see if that can be factored as a difference of perfect squares. So we take the 1's off. Those are not needed, either one of them. So I bring over the x minus 5. That's F1. Now here we have positive, negative. Okay, so it's a difference. Now are these perfect squares? Well, x second is because that's x times x. And then 4 is a perfect square because that's 2 times 2. Again, difference of perfect squares. So xx, 2, 2. So I replace this with these two quantities here. So f1, f2, f3. So x minus 5 could equal 0. X plus 2 could equal 0. X minus 2 could equal 0. So we add 5 and we get 5. We subtract 2 and we get negative 2. Then we add 2 and we get positive 2. Okay, number 7. 4 times the quantity x minus 2 equals 24. Now I have x inside of a quantity with a minus 2, but there's no power, so I distribute like I normally do. Okay? Distribute that 4. So there's only one answer. This is distribute. So 4 times 1x is 4x. 4 times negative 2 is negative 8 equals 24. Then I use my linear properties to solve for it. So I take out the negative 8 with plus 8. Then I get rid of the times 4 with divide by 4, but I don't apply the square root. I just add 8, and that's 32. Then I divide by 4, and 32 divided by 4 is 8. Okay, number 8, we have 4 times the quantity x minus 2 to the second power equals 24. So we have x minus 2 again, but there's a power there, so you cannot distribute. You are blocked. So you want to bring in h. Okay. So there's two answers for x. You're to solve for x. Now you're going to remove the quantity and replace it with h. So you have 4 times h to the second power equals 24. Now you're going to need to make a table to bring back your x minus 2 after you have solved for the h. Now there's two sides because to solve for the h, we have to divide by 4. There's no plus or minus. And then you have to do the square root. And the square root always results in a positive and a negative. So I will divide by 4 here. I get 6. Now the square root of 6 is not 3. The square root of 9 is 3. 6 is not a perfect square, so it's an irrational square root. So the square root of the value 6 is irrational, 2.45. Now those are not your answers though. You still need to put those over here. And then you can solve for the x, which is what you're supposed to do. So you add 2, and that's 4.45. Then you add 2, and negative 2.45 plus 2 is going to be negative 0.45. Okay, now it's time to do some story problems. An object is thrown into the air, I don't know why that U's there, with a velocity of 100 feet per second from a height of 8 feet. So 8 feet your starting height. After how many seconds does it hit the ground? So seconds. So obviously seconds is an important unit, but there's got to be another unit with it, and that would be feet. Feet's dependent upon the seconds. You're solving for the independent variable. So x is seconds, y is feet. So the feet per second is 100. Okay, it goes up and down, and it's pulled up and down by the force of gravity, which is negative 16x to the second. Okay, so I mark where it starts at. It starts at 8 feet, and I mark where it finishes at, which is the ground. That means 0 feet. And I put question mark under that, and then seconds. Okay, so I've got x second, x constant equals y. So negative 16 and 100 occupy the gravity and the acceleration rate, and then this 8 goes in the constant. Now 0 feet goes into the equation for the y variable. So remove the y from the equation, put 0. Now we've got x to the second and we have x to the first, two same variable, different degrees. So we have to use factoring properties. So there's two answers. And the zero's there, you can check that. And it's three terms, so it'd be a trinomial. So GCF, and then difference of perfect squares. Or no, and then the t-chart, my bad. It's three terms. So there's no x, there is a negative. Now 16, 108. So you'll check 8 and 16, but then no 100. So here's 8 again, 16, and there's 100 at the end, so we can factor out a negative 4. Okay. So I factor negative 4 out. So now I'm at 4x to the second, negative 25x, and negative 2. Now this is your trinomial you're going from now. So 4 times negative 2 is negative 8. So it's a positive negative because the signs have to mismatch. And you are adding to try to get to negative 25. Well, right away you're going to realize 8 divided by 1 is 8, and that adds to negative 7. So already you're under where you need to be. So it's too narrow, so that's quadratic formula. So opposite of b, opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a. Over 2a. So the opposite of b is positive 25. b, that's going to be negative 25. And then 4ac, so a is 4, c is negative 2, and on bottom a is 4. Okay, so in front you have 25. On the bottom, 2 times 4 is 8. Now you fill in the square root with what the value is going to be, negative 25 to the second, minus 4, 4, negative 2. So I got 657. So it's a positive or a negative, and the square root of 657 is going to be 25.63. Okay, so 25 plus 25.63, click equals, and then divide by 8, and you get 6.33. 25 minus 25.63, click equals, divide by 8, negative 0.08. So 6.33 is the number of seconds. Okay, next one. A 10 by 12 foot pool gets a walkway added all the way around that's the same width on every side. After the walkway is added, the combined area of the pool and the walkway is 288 square feet. What is the width of the walkway? Okay, so we're talking about a shape here, are we not? Yeah, we're talking about a shape. Okay. Or wait a second, get rid of this problem. Okay, I don't want to do that one. Okay. Go to the next one. A 14 by 17 foot garden gets a walkway added around it that's the same on every side. The combined area of the garden and walkway is 418 square feet. What's the width of the walkway? They're the same problem essentially, just with different values. Okay, so we're talking a rectangle here, and that rectangle is 14 by 17. Now you're building a walkway around it, so now you recalibrate your dimensions with variables. So you have 14 and 17, but this outer border is what we're trying to figure out, so we label that X all the way around because it's the same every side, so that's why I can use the same variable. Okay, now in a shape problem, we want to write the formula for the area. Or this one would be area because square feet means area, so 418 is your area. Now you have 2x plus 14, and you have 2x plus 17. So you need to apply the FOIL method to solve. First, 2x to 2x, 2x to 17. out, and 14 to the same two things. So 14 times 2x, 14 times 17. So that's 4 with x second, that's 34 with x, that's 28 with x, and then 14 times 17, I don't know that off, it's 238. So we got x second, x, and the constant. So 4. Remember, it's important you simplify your product by adding the like terms. So 62x, and then 238. So I write 4x to the second plus 62x plus 238 equals 418. So now I can go to my process of solving. It's not really a story problem anymore. I see that I have x second with x, so you have to apply your factoring properties. So there's two answers, okay? Got to have 0, so subtract 418, and you can do that with the positive 238. So you have x second, x, and constant. So you have 4, 62, then 238 minus 418 is negative 180. Okay, 3 terms, GCF table. Okay, I do not have an x on the end. I don't have a negative in front. Now 4, 62, and 180. Now if you look at 4, it skips over 62, so we can't do 4. Now 4, the chart's not big enough. 4 is also in the second row. Now I know this chart's not big enough to see if the 2 row goes to 62 and 180. It cuts out at 50. So you're looking at the 2. So take all of these and divide them by 2. If none of them are decimals, we can go ahead and put 2 out there. 31. No decimals, so 2. These can all be divided by 2. If the chart were bigger, you would see 2. You would see all of them across the 2's row. Okay, so now I got 2x to the second plus 31x, and then that's going to be negative 90. So I bring out my 2. Won't really need to use it, but 2 times negative 90 is negative 180. Now what have I always said if we have something above 100? That means we're going to go quadratic formula right off the bat. So opposite of b, plus or minus the square root, b squared minus 4ac, b squared minus 4ac over 2a. Over 2a. So opposite of b is negative 31. Then b to the second. So 31 to the second. Then a is 2. C is negative 90. On the bottom, the a is 2. So you won't be needing this, okay? So you have a negative 31 in front. 2 times 2 on the bottom is 4. Now I make my square root. Now I got to find the value that goes inside of that. So 31 to the second minus 4, 2, negative 90. 1,681. And then I find the square root. I'm pretty sure this one is not irrational. 41. And what that means the T-chart would have worked if I'd have felt like wasting time with it. I would have eventually found them, but remember what I've said about that. So negative 31 plus 41 is 10, divided by 4 is 2.5. Negative 31 minus 41 divided by 4 is negative 18. So obviously the positive 2.5 makes more sense. So all these x's are 2.5s. 2.5, 14, 2.5, 2.5, 17, 2.5. Okay, then the last problem. Different than the others. A community theater sells 150 tickets to a play when it charges $20 per ticket. For each $1 decrease in price, 10 more tickets are sold. What is the maximum revenue the theater can raise? Now, maximum is completely different. a maximum, any maximum is found with that's a vertex. And it is found with the formula opposite of b divided by 2 times a. So if I'm finding a vertex, I just draw a big parabola in the middle with a coordinate point where I put opposite of b divided by 2 times a. See, that's my vertex point. Okay. Now, I know that this needs an equation, so x second, x constant equals y. Okay, so negative 16 is my x to the second. Or no, not negative 16. Sorry, this is not height, this is revenue. Okay, y is revenue. Okay, now the formula to find revenue is different, okay? You need to set up two separate quantities, one for money, one for items. And then to know how to fill that in, you're going to want to make a table down here. Money, items. So you're going to put your 20 with the 150. Then what are you doing to your money? Well, you're decreasing it by 1, and you're adding 10 every time you decrease it by 1 to the items. So it's going to be 19, 160, then minus 1 again, you're at 18, and then 170. Now that keeps on going. See, and if you want to, this is not mandatory here. The table probably is, but not. You can multiply those across. So he'd be making a revenue of $3,000 that way. But if he goes down by 19, now he's selling 160. Now he's up to $3,040. Then 18 times 170 is 3,060. So as you can see, that's going up. Okay, well, when does it stop going up? That's the question. That's what this figures out. So the money, you got 20. And you got 150 for the items, and you're subtracting 1 from the dollars. Now we don't know how many ones we're subtracting, so it's 1x, and we're adding 10 for the items. We don't know how many 10s we're adding there either. So I need to do the FOIL method. So I distribute 20 to 150 and 20 to 10x. Then negative 1x to 150 and negative 1x to 10x. So that's 3,000. This is 200x. This is negative 150x. This is x second with negative 10. So negative 10 is my x to the second. Okay, there's my a. Now the x's we add, and that's 50. That's your b. We add these two terms in the 3,000. Okay, now the opposite of b would be negative 50. 2 times a. So a is negative 10, and that's negative 20. So then you divide these and you get 2.5. That means 2.5 changes in price. Okay, and you're like, how do you change it? Well, you go down a dollar, and then down 50 cents. Okay, would be how that works. Now you substitute 2.5 into the equation for x. Okay, and I will substitute that. So I've got negative 10, 2.5 to the second, plus 50, and then 2.5 plus 3,000. I get $3,062.50. And that's your maximum revenue. So you can get a decimal, yeah, because money, you can have 50 cents. Okay.